Frank works as the tech lead for data platform team at TikTok US, and the focus on OLAP distributed systems. Before joining TikTok, Frank led the data infrastructure team at Optimizely and worked as the founding engineer at Mailtime. And Frank's talk might actually be of great help for those of you who are currently using Alluxio with Presto, and as he will show you how TikTok's approach and adopting Alluxio for the cache layer without introducing some additional services. So if you guys are wondering how that is done, let's welcome Frank Hu for improving Presto performance with Alluxio at TikTok. Go ahead, take it away.
Hello, can you see my screen? Hello? Okay.
I think
yes, we can see your screen. Great. Let's get started. Hello, everyone. Good morning. I'm Frank, working at TikTok. Today, I'm going to share you with our journey to adopting Alluxio cache to improve our Presto performance. So this is a very quick view about what I'm going to cover. First, I will briefly talk about what do we use Presto for, like our TikTok scale Presto clusters. Second, I'm going to talk about like our own integration to have the Presto works together with Alluxio, which may be different from the open source version we have seen in the community. The third part, I want to talk about when we enforce caching, how do we customize the caching strategy? How do you really schedule the cache to be there so that the cache hit rate will be higher and the caching will be more efficient. Cool. So a little bit of intro about our Presto use case. Like I think very similar to the previous talk. We use Presto to query our Hive tables on HDFS. And so far, every day we get around 600K read-only interactive SQLs, and the cluster size is as listed. So there's a few things I want to highlight, especially about the data source part. The first, like our major data source is still Hive table that lives on HDFS. The second is like our Presto engine use a shared Hive meta store with other engines databases, including Spark and ClickHouse. So this will be a great factor when we consider how we integrate Presto with Alluxio. So this may sound like a very naive question, like why caching, or why caching comes as the first place when we think about optimizing latency on Presto. Given Presto is like MPP model query engine, I think the latency is what Presto is really optimized for. While we analyze all our SQLs on Presto, the first bottleneck or time-consuming part we identify is on the I/O. I think that's aligned with the previous talk on the Raptor X, saying that if you do the data caching, they see like 10x to 20x performance improvement on the I/O. Another problem we also notice will be like the slow HDFS data node, which if you have like very high concurrent reads on the same batch of blocks, you will see some data nodes intend to be very slow, which will block execution of all the query reading from that. The third part is like, if you don't do the caching or like especially the local caching, I think your workers compete for network bandwidth. The network bandwidth on Presto is not only used for I/O reading during the shuffle stage. There will be also a lot of network traffic going on within those Presto workers and the coordinators. So if we save some bandwidth on initial table scan, that can free up the network bandwidth for other SQLs. Great. So yeah, just catch it, right? We have a lot of caching. Alluxio is great, but why? What's the downside of adopting a cache? I always joke like the best cache is no cache, because the implementation of a cache can become very complex and introduce a lot of problems when you think about it. I just list a few, but I believe there is a lot of problems. The few things that we highlight will be like consistency. We use caching. Caching will definitely improve your I/O speed. However, there's always a question like, what if the cache is inconsistent with a remote database or remote data source? What should we do? The second thing will be like data locality, which is more or less equal to the cache hit rate. In Presto world, we really want like one worker could always hit the cache rather than like fetch cache from other workers or from the remote data source. I'm not going through this problem one by one because everyone have developed any query engines or web applications must be familiar with like difficulty to debug this problem in production. But I think the good news is like I see Alluxio is a good fit for almost all the questions I listed here. For example, for the consistency, Alluxio have the active sync. For the data locality, Alluxio have the, I think it's called dynamic replica, which can increase like the replication on each block. So I think after a lot of initial research, Alluxio seems to be a good fit that already provide a lot of features that can solve this problem. So yeah, it's great. How about just like use Alluxio out of box? So the first problem we encountered to adopting Alluxio, we'll be looking at how Alluxio could work together with Presto. In open source code, we noticed there's two solutions. It's either in the code or in the document of Alluxio. The first one is my own naming. I just call it like a hard code URL swap. What this means is basically you can change the location properties in the Hive meta store table partition. Previously, if you use Hive, you should have the prefix of the HDFS. And if you swap that to Alluxio, of course, your Presto can directly read from Alluxio path. I think this approach is very good for POCs or just like do some quick setups. However, when it comes to production, at least in our scenario, like the location information is not only used by Presto. Actually, it's a shared metastore information that lives in Hive metastore that a lot of engine could read or write to. So if we're going to adopt this approach, this basically enforce a prerequisite that like all our engine must read and write to Alluxio, which may not be applicable, especially on our rollout with Alluxio. The second integration I have seen is a service called Alluxio catalog service. I get a graph from the Alluxio doc. Basically, I think this is like a proxy in front of the Hive metastore. Of course, it does its own smart things to optimize the catalog layout. But the problem we see here is basically if we adopt this service, every call to let's say get a block or list a file to Hive metastore, that call must go through Alluxio catalog service, which can introduce very high QPS on the Alluxio MAS clusters. Compared to our existing approach, I think our HDFS infrastructure has been proved to handle the traffic that we can the Presto can hand over to HDFS, but Alluxio master may not be as scale up as what we have seen. And also this may intend to be a lot of like waste of round trip, because we probably let's say you only want to cache a certain portion of your Hive tables. For those who are not cached, you still have to pay the round trip that you talk with the Alluxio catalog service. Another problem we have found is like currently I think it requires a manual synchronization between like the Alluxio catalog service and the Hive metastore. You have so every time if there's any change on the Hive metastore, you probably have to call command to sync this difference. We do brainstorm together with the community, and we think there is a way to solve this problem. However, that still means an extra step that you need to do to make the integration happens. So let me talk about how we integrate our Presto with Alluxio. The solution is actually quite straightforward, because potentially you basically need two paths from Presto side. One is the original HDFS path. The second one is the optional Alluxio path. One way to do that without changing the Hive metastore API is like you can store the catch path, which means the Alluxio path, in the table of partitions parameters. So I think for each table and the parameter partition, there will be a parameter list which you can add in freeform key values. So that's basically where we add the key called like catch path, and we add the Alluxio path there. So we do make some modification on Presto side. So when the Presto coordinator load the location, path informations, we actually do load both. So we load an HDFS path and we load an optional Alluxio path. And the logic, of course, that can be controlled by a feature flag, or it's like if the Alluxio path presents, then we'll read from Alluxio path first. So this will be a very simple change on Hive Metastore and Presto, but that enable you to have certain table that is cached in Alluxio and didn't introduce additional round trip to any like third-party service. Another improvement we have added on the integration is like since we use Alluxio mainly as a read-only cache for now, we do want to see the cache, so we'll always think about like fallbacks. Actually inspired by the local cache, I think in Presto there's a class called Alluxio caching file systems. You can see that you can have more than one file system integrated in one class and can fall back to each other. So that's basically what we do. So we extend on the Presto side, we extend the caching file system and have both two file systems, one for HDFS, one for Alluxio in that class. And our logic is like if any reads on Alluxio fails or timeout, or we can fall back to HDFS. We don't really see a lot of like fallbacks in production, but if you start with like adopting Alluxio, you always have that safeguard here in case anything is wrong, or just like your Alluxio cluster is restarting or upgrading. So in summary, we do store like two paths on Hive Metastore, and we modified both the Presto code and Alluxio code a little bit so that we can prioritize reading from Alluxio as the cache, and if we fail, we can fall back to HDFS automatically. Great. After we have done this, we just run a very quick benchmark on a few data sets. The initial result is pretty promising. It's like on a few sample cycles, we have tried to optimize the latency. We see around 30% of latency reduction. However, as we do like more generic benchmarking, for example, on the TB-CDS benchmark set, we noticed that benchmark fall to 17% instead of like 30% we have seen. So we look at those cycles and try to understand why the end-to-end improvements decrease on TB-CDS. And one learning we have seen is basically you have to identify those IO intensive cycles in order to maximize the benefit bring back cache. By that I mean if your cycles are heavy on joins or on aggregations, which is more intended to be like CPU bounded, then apply a cache will only optimize certain parts of the cycle execution, and that will not contribute too much to the end-to-end improvement. That's why we're trying to enforce or apply our own customized cache strategy that will basically define like which table that should be cached. We don't want to like blindly catch all the tables, or we don't want or the LRU caching policy provided by Alluxio may not be sufficient for us. So we try to further optimize it further based on our own query patterns. So the way how we do it, basically we start to collecting some data on the Presto side. On the right-hand side, this is basically, if you are familiar with Presto, on each of the cycle, Presto will basically generate a query info JSON object that are containing a lot of meta information on each of the stage and the operators on the Presto SQL execution, and which are most relevant to Alluxio, which is IO cache for now. We are focusing on two operators. One is table scan operator, the other is scan filter and read scan filter and project operators. Those two operators basically stands for the initial read from the remote storage. And as you see, based on this JSON that you collect on each of the SQL, there is time that you spend on it, and there is data size that you spend on the read. So based on those informations, actually, we can aggregate them and create our own cache strategy based on this. Our initial version is actually quite, I would say, straightforward or naive. Basically, we just aggregate the top n time-consuming partition in the past m days. The n and m really depends on like the time range of your Hive tables, as well as like the size of your Alluxio cache. And once all these data are collected, the strategy is basically doing a knapsack, trying to solve a knapsack problem. It's like giving a fixed Alluxio space. Let's find the best set of partitions and TTL that we should catch. So once this strategy is here, we also need to have a way, as I introduced before, to monitor when the Hive meta store changes, how do we enforce this catch, or how do you apply these strategies? That's why we create a new module called catch scheduler. This catch scheduler is basically doing two things. The first one is on triggering. It subscribes to the Hive meta store change log on like those operations that will make a change to your partition information, which includes add, alter, or drops. And once it receives those events, it will check, like in this partition, check with existing catch strategy to determine whether the newly added partition should be catched or not. And what if the partition need to be catched? Basically, the catch scheduler will start to mount this partition in Alluxio first, and also modify the catch path in the Hive meta store. Another part of what this catch scheduler do is basically it will have a cron job, because our catch strategies will also include TTLs to define like how long we want this catch to live in Alluxio. So we also have a cron job that will periodically clean up from both Hive meta store and Alluxio to make sure our catch strategy is aligned. So this will be our overall architecture so far. As a quick recap about the two parts I've talked about. If you start from the Presto coordinator, so on every execution, Presto coordinator will basically post the JSON that I'm showing in the previous screenshots as the query stats that will contribute the calculating of the catch strategy. And on the reading side, let's say if you are read and SQL, Presto coordinator will load both the HDFS location as well as the optional Alluxio catch meta information and pass those informations to Presto worker. Presto worker have the flexibility that if the Alluxio path is present, read from Alluxio path or fall back to HDFS if there's a catch miss. On the other side, the catch scheduler will keep monitoring any change log that happens catalog service, and it will make a decision. I mean, after checking with the catch strategy that we have, it will make a decision to whether you need to add the catch path in Hive meta store, as well as like mount those newly added partition in Alluxio clusters, or do other logic if needed. So far, let me share like our final results on the first adoption of Alluxio combining these two integrations. Actually, the result is pretty good for us. So our P95 of Presto query latency has reduced by more than 40%. Of course, we have not seen like 10x improvement that the RaptorX have. That's what we digging into to understand like what's the potential performance that we have. But at least when you compare our HDFS speed with Alluxio speed, I think the improvement we see is aligned with the latency that we have seen so far. So the throughput increased by around 40%. That's why the end-to-end latency reduced by 40%. About the catch coverage part, so with less than 1% of the catch, our Alluxio space, whereas our daily HDFS increments, we are able to reach around 30% of SQL level catch coverage on weekly basis, which means that more than 30% of the catch based on the previous catch strategy, we have to calculate hit the catch in our use case. And on all these catch hit SQLs, we see like 90% of the SQLs have significant improvement. The reason we choose like 20% is because the execution time may not be always stable on Presto. It depends on your workload, and it depends on the parallelism of your Presto cluster setup. So in our use case, we define like if the performance have improved more than 20% as significant improvement, and you can see that 90% of catch SQL reach this improvement, which means that the Alluxio catch is effective for us. Cool. I also want to talk about like the ongoing things, because we have been adopting Alluxio since last year December, and what is the next step that we're trying to collaborate more with the community. The first one, we are also looking to a solution as it has many names like Alluxio as library or embedded Alluxio, which is very similar to the RafterX architecture in the previous talk. But we do want to make a few modification or optimization in order for us to adopting it. The first thing will be the cache consistency. In our use case, or I think in general use case of Hive tables, you could not make the assumption that the remote data source will always remain the same or immutable, which is the assumption that I have in the current implementation. So I do link an issue on Alluxio, and we are planning to contribute that feature back to the community. We're trying to use the last modified time that on each of the files as a versioning, so that we can distinguish whether the local cache is out of date or which we can use. The second optimization is probably more on the Presto side. I think in the previous talk, Beinan and the speakers also talk about this. Is like currently, I think the current existing cache algorithm on Presto affinity scheduling is basically mod how many workers. So if let's say one worker goes down, then the distribution of the entire cache will be different. So we do want to optimize this scheduling algorithm so that if we lose one worker, we'll not see like immediately all the cache hit rate goes to zero, because like rebuilding that cache could be expensive as well. The third aspect we're looking into is we really like the idea of Alluxio structured data. This is basically a transform service that allow you to modify the cache a little bit. Is either change the format of the cache or just unzip that to translate into more sufficient format. Unfortunately, we only see this feature in the distributed Alluxio cache, which also trying to see whether we can have this feature or partial of the feature set in the Alluxio as a library, so that it enable us to just enforce more fancier caching strategies in the library version. Another part we are aggressively experiment with is like currently we only use Alluxio as a read-only cache. We do want to enable some scenario to use Alluxio as a write cache. One common scenario we have seen is like if you have a lot of ETL jobs, one depend on each other. Basically, for the intermediate results, either we'll all need to write to HDFS, and the following job will read from HDFS again. So we're trying to see whether we can enable a write cache on Alluxio that serves as an intermediate stage, so that it can change different ETL jobs. So they don't need to read from HDFS, which is the remote data storage. They can rely on Alluxio for that. Cool. I think that's pretty all the talk, all the material I've been prepared with, and I'm working for TikTok, so TikTok is hiring. If you have any questions, feel free to find me on a Slack channel or just ping me via emails. I will see if there's any questions we have.
Cool, thank you, Frank. So I actually have Jian here from our team, who's going to be probably working with you quite often from now on, and see if he's got some questions for you.
Yeah, it's very impressive talking. Thanks. And I have some questions about the cache strategy. Could you elaborate more on the details of the strategy?
Okay, great. I'm going to switch back to the slides. Let me see. Yeah. So what are we trying to do is like we're trying to control the cache on the partition level, which means that oops. Let me reshare my screen again. Sorry. Yeah, I think you can see my screen, right? So so we're trying to do is like we don't want all the table to be cached, because like or mount the entire HDFS namespace into Alluxio. That could be a lot. So we try to be very selective about like which partition that we're trying to put into Alluxio. However, the reason we want to have a cache strategy because our Presto is actually running multi-tenant use case. So there's a lot of the team that just submit different ad hoc or interactive queries on the same clusters. And most of them we see like there's a few very concentrated tables that have been queried repetitively. So basically this cache strategy is used to identify those tables. However, why we want to like identify them in like table scan operator and the scan filter and the project operator is that we notice if the table or partition is too small, basically the benefit that we get from caching this table, it's, I will not say no, but it's negligible. That use case could be because our internal HDFS is actually, the speed is pretty fast. We're able to read around like 1 gigabytes per second from that. That's why if the table is too small and we catch it, you just basically just waste some resources on the Alluxio side. So we try to be very critical about like which partition that we catch. That's why we build this strategy and we scan all the SQL that we submit to Presto and identify those exact partition that we have. The result of that will be, you can simply imagine the strategies provide a list of partition, and on each partition we add a TTL. That TTL is corresponding to the partition. Let's say if your table is partitioned by date, then that TTL could be like 3 days, which means that we will make sure the partition for that table in the past 3 days are all cached. So that's basically the idea behind the cache strategy.
Okay, thanks. Well, I have another question from the community, which is like, write cache is a challenge. Like, what do you think the challenge would be for the enabling the write cache? And what's the use case except the ETL? Do you think there's other like use cases for the Presto writing data in TikTok?
Yeah, got you. I think in our scenario, it's mainly on the scalability part. Because when we do a read-only cache, especially with the LRU strategy that Alluxio already has, as well as the cache strategy that we already has, we have an idea about roughly how many data that we want to catch in Alluxio. That's for read cache. However, that assumption cannot hold for the write cache, because you could not say, hey, I'm going to truncate certain part of data. And when the speed until the SQL finishes, it's very hard to predict like how many what's the data volume that you're going to write out to Alluxio. So I think that's the main challenge we see so far, which means that probably we need to scale our Alluxio cluster furthermore. That may not be even beyond like the scale of one single Alluxio cluster, which we have co-located with one Presto cluster for now, which means that we could have probably want to do a cluster federation to allow split the traffic across multiple Alluxio clusters. So I think that's the main challenge we have seen so far. Yep.
Okay, thanks for your answer. It's, yeah, I think I'm good.
Okay, cool. Thank you so much. And then thank you again for Frank and Jinjin. And then, like we said, you guys can follow Frank on our community Slack if you have any questions for him. And then he's also quite a frequenter at our community weekly DevOps Syncs. So if you guys have any question or you have some similar use cases that you would like to discuss with our community members and contributors, feel free to join us.